Good afternoon, everybody. I am really excited to be here with you again today. I hope you are all doing well, given the times and everything with the quarantine and social distancing. I hope everybody's hanging in there all right. I hope everybody is kind of knows what's going on with their schoolwork now, and maybe some anxiety from that is a little bit relieved. I know from the teaching end, after we're one day down, I feel a little bit better about it, and I hope you guys as students feel better about it as well. I know I miss seeing my students, and I'm sure you all miss seeing your teachers as well, wherever you're coming from. So today what we're going to do something a little bit different. This was fun for me because it allowed me to kind of jump into something a little bit new in AP Stats. We're going to look at exploring two variable data, and we're going to look at two aspects of the AP Statistics course exam description that were added for the 2019-2020 school year. So for this upcoming exam, these two topics were added, and they both have to do with two variable data. So it was fun for me over the weekend to kind of explore a new topic and look at some new aspects for AP statistics. And I hope you guys kind of enjoy this as well. Make sure that you kind of take note of all of the streams that Fiveable is offering in this time. I think Fiveable is a fantastic tool. A lot of really highly qualified teachers in pretty much every AP subject that you can get some instruction and some review for. So make sure you log into those if you're taking other AP classes. Monday is the day we focus on math and some other subjects, and Tuesdays social science, Wednesdays science, Thursdays history. So a lot of great teachers out there that can really supplement what you're doing with other places to help you prepare for your AP exams. So check those out. Some upcoming streams for AP Stats. Next week, we're going to focus on the normal distribution. We're going to look at primarily how can we use our calculator to calculate certain things, and how can we make sure that we show our work well if we're using a calculator. So be sure to log in, same time, same place, on Monday, April 13th at 7 p.m. Eastern, 6 p.m. Central. All right, and then we have some other upcoming topics as well that we'll talk about closer to the time. Be sure you follow Fiveable on Twitter, Instagram, YouTube, all of the all of the social media platforms. They're constantly putting out content that you guys can take advantage of. Okay, so follow them there and make sure that you keep up with all the awesome things that they're putting out. Okay, I'm going to add captions on real quick. That way you can, if you're writing things down, you can keep up with me a little bit better. Okay, so particularly in this stream, in this event, the two main focuses that we're going to look at are really three. The first one is we're going to look at mosaic plots. That was something that was added into the course exam description this year, and it was in Unit 2, which is on two variable data. We're also going to do a little bit of a review of linear regression and least squares regression lines. Now, let me tell you, if you want more review on that particular topic, later on tonight, my colleague with Fiveable is going to be doing a stream as part of the cram pass that is breaking down all parts of regression. So if you need more review, which if you're like me, it's one of the topics that I'll struggle with a little bit, you definitely probably want to hop over there and take advantage of that cram pass. I think there's still some available, and you can get some good review for Unit 2 overall. And then the third thing, and this kind of builds off of the review that we have on regression, is we are going to look at what happens when the data departs away from being linear. How can we edit our data a little bit to make it so that we can fit a linear regression line to it? So mosaic plots and that departure from linearity were both new this year to AP statistics. So we are going to dive in and look at those two things and how they relate to two variable data, also some probability incorporated with mosaic plots, and of course linear regression incorporated with the departure from linear. Because basically we're going to take data that is not linear and we're going to do something to either the x coordinates or the y coordinates, and it will transform the data so that it does make a linear curve. Okay. So first up is mosaic plots, which is they're pretty little plots that we can get that are a more graphic representation of things that we normally will see with a two-way table. So it's also known as a contingency table. A lot of research I did, that name kept popping up. Also, a Marimekko chart is another word for that. Another name for a mosaic plot. AP Stats typically always is going to follow the vocabulary that is in their course exam description, which is mosaic plots. And it is used to graphically display a two-way table. So instead of just using numbers and raw frequencies, we are going to use that to display it graphically using almost like a segmented bar chart, but several segmented bar charts all put together. And then also even those bar charts are sized differently. Okay, it gives you a two-dimensional look at a segmented bar chart. Maybe that's a good way of looking at it. It was really cool to put that together. So it's going to utilize both dimensions. It's going to utilize the x and the y axis. Okay, so the explanatory variable, which is your x, and the response variable, which is your y. So it's going to take advantage of two axes to help you to analyze tables graphically. Okay, so the example we're going to look at has to do with what flavor Taki certain classes in a school preferred. So we have freshmen, sophomore, juniors, and seniors. And they were asked which of three Taki flavors they preferred. Did they prefer the Fuego, which is probably the ones that you may be most familiar with? It comes in the purple bag. Okay, those are one of my favorites. Last week I talked about cookies from the cookie jar in our quarantine snack food days. And then this week we're looking at Takis. So I guess I like snack food, and that's what's been on my mind a lot lately. So Fuego is represented with that awesome teal-ish color. And the fajita Takis are represented with the orange. And then the not so well known and also not so well liked, obviously from our data, the zombie Takis represented with like a gray color. And you can look at that and you can see kind of how things are laid out there, and what we would look at. So I'm just going to ask a few questions, and you can answer over here in the chat. Be sure that you look at the bottom on the where you see you have ask a question. If you have a question you want to ask, chime in on there, and also on the chat over here. You can also chime in as well and ask questions and that sort of thing. So take advantage of those. Those are great tools that help me to be able to answer your questions. I don't want this to be a one-sided video. I want it to definitely be one that we all kind of come together and make sense of what we're looking at. So a few questions, and then we'll while you're looking at the plot. And then I've got some other questions as well that are more typed out that we'll kind of look at that provide a little bit of review. So which flavor Taki is preferred among juniors? So y'all take a minute and answer in the chat. Olivia says fajita. Kate says fajita. Hannah says fajita. Kirsten says fajita. Most people are saying fajita. So good job there. So if we're looking at juniors, so we're looking over here at this, think about it like segmented bar charts. Okay. And the juniors are this segmented bar chart right here. And the most popular flavor for them is fajita, which is the orange block there. It's because it's largest. Okay. All of these go from 0 to 100%. Just like a segmented bar chart would be. So the orange takes up the most of that 100%, which is the fajita flavored. As some of you said, shockingly. Okay. Overall, which flavor do you think is the most popular? Okay, seeing a lot of fuegos. That's good. Now, let me just kind of caution you on that. Um, and it kind of gives us a chance to talk about the other aspect of a mosaic plot that we know. So if you were looking at three equal segmented bar charts, you could not make that conclusion that Fuego was the most popular. And the reason why, because what if there are 800 juniors who took the survey and there are only 100 freshmen, 100 sophomores, and 100 seniors? Okay, well, then that would mean that Fajita would be the most popular because the junior had a lot more numbers. Okay, now the cool thing about a mosaic plot is that the width of the bars all reflect how big each class is or how many people belonged into that category. So not only is the percentage going from 0 to 100 on each segmented bar chart here going up to show what percentage of freshmen preferred Fuego and what percentage of freshmen preferred Fajita and so on. There's also a 0 to 100% going horizontally that that can give us an idea about the raw counts of the freshman, sophomore, junior, and senior. Now, with this particular example, it's pretty close to being all equal. But if you look close, you can tell that some of the width of the classes are a little bit different. Okay. So let's see. Which class had the most students, the senior class or the freshman class who took the survey? So y'all chime in there. Olivia says senior. Josie says senior. Kirsten says senior. Allie says senior. Okay. Yep. And you can tell here the senior bar chart is a little bit wider than the freshman bar chart. Okay. It's kind of hard to see. They are pretty close to being the same, but the senior one is a little bit wider. It's not the largest class. We'll get to that more in just a second. Okay. All right, so let's look at some example questions, and I can bounce back to slides after we ask the question if we need to. So first one, which class appears to be the largest and explain why? Okay, so keep that question in mind and answer that now that you can look back at the mosaic plot. So which class is the largest and why is it the largest? Give y'all a second to chime in on the chat there. Okay. It is hardest to tell. It is hard to tell. Everybody seems to be saying junior. We have a senior. Sophomore because they have the largest space taken up on the x-axis. That would be good. That's another good explanation. You could say I wouldn't say the largest box, Josie. I would say the widest box because largest could be, you could be referring to height and then it's not actually I guess they all have the same height. So you could say something like it takes up the most area. That would be true. The reasoning is good. And this one, it is hard to tell. And I think the fact that the fajita on the junior throws things off a little bit. The correct answer is sophomore. So the sophomore is a little bit wider than the junior and the senior. And again, it's hard to tell. If I could go back and do this, I would make the sophomore, significantly wider. That way you could tell a little bit easier. But y'all's reasoning was good. If you were given a question like this on the AP exam with a mosaic plot, I think the answer would be very obvious. And with y'all's reasoning, you would be fine. Okay, so let's look at the next example here. The next question. Do the events zombie and freshman appear to be disjoint? And another word for that is mutually exclusive. So again, a little bit of probability review in here. We'll get to probability a lot more in depth in a few weeks in our streams with the cram pass and the free stream. But the Mosaic plot gives us a good chance to look at that. Do the events zombie and freshman appear to be disjoint or mutually exclusive? Okay. So freshman and zombie, do they appear to be mutually disjoint or mutually exclusive or disjoint? Okay. Good. Good. If you have to open up a second Google Chrome tab to Google what mutually exclusive means right now, that's acceptable right now. I'm not so sure that'll be acceptable on the AP exam test date on May 22nd, but right now I think that would be okay. Okay, Kirsten and Josie pretty much nailed it on the head there. Because there are no freshmen that preferred zombie, okay, that means they are mutually exclusive or disjoint. Those two events never overlap, is what Kirsten said. So that would be a good explanation there. Mutually disjoint or exclusive, okay, means that they don't occur at the same time. And there are no freshmen that selected zombie. So therefore, those two things do not occur at the same time. Okay. So that would be your answer on that one. That's one of those probability words. I wanted to throw that, to kind of throw that in there and make sure that you had seen that before. Not mutually exclusive, because knowing the knowledge of one is not. Okay. I think that's the definition over here for independent. So if one affects the other one, then that is independence. And you can be, two things can be independent of each other without being mutually exclusive, and vice versa. Okay, so for C, that's what we're going to look at. Junior and fajita, do those appear to be independent? So let's go back to our Mosaic plot. Junior and fajita, do those appear to be independent of each other? Okay, I see some no's. Okay, I got a yes. All right, so let's look at this one real quick. Okay, I think I have the answers to A, B, and C on this one. All right, so A, the sophomore class appears to be the largest because its bar is widest. We've already discussed that. The events zombie and freshman do appear to be disjoint because there are no freshmen who prefer the zombie flavor. Again, mutually exclusive or disjoint means they don't, they do not have any overlap, or there's not a freshman who preferred zombie. And in that case, that's what makes them disjoint. And for C, okay, the events junior and fajita do not appear to be independent because it appears from the Mosaic plot that juniors are more likely to prefer fajita Takis than the other classes. Okay, so let's go back to our plot. Okay, so the probability of selecting fajita is not equal to the probability of selecting fajita given that you're a junior. So the probability of selecting a fajita given that you're a junior is higher than the probability of selecting fajita overall. Therefore, those two things are not independent of each other. For some reason, the junior class seems to really love the fajita Takis. okay, for whatever reason it may be. So therefore, they're more likely to say, yes, fajita is my favorite, as opposed to if you just randomly selected a student out of the whole survey. So if I select a student out of freshman, sophomore, junior, senior, the probability, as a proportion from 0 to 1 is going to be lower. The probability of selecting someone who prefers fajita is going to be a lot lower than the probability if I selecting a person who prefers fajita just out of the junior box. Okay, so therefore they are not independent of each other. Okay, based off of the numbers and the widths of the charts we have, you are more likely to choose fajita if you're a junior than you are to choose fajita overall. Okay, because that fajita box is a lot larger in comparison to the fajita boxes on the other 3 classes. Okay, and they were all pretty equal in width. So, we can kind of draw to that conclusion. We don't have the raw numbers here to, to prove independence. That's why I kind of added in this wiggle word. They don't appear to be independent. We didn't say they're not independent because we don't have the raw numbers to actually prove it, but we can make that sort of conclusion there that they appear to be independent. Okay, now here is the two-way table that I used to create the mosaic plot, which is probably more like what you are used to seeing. Okay, so we had 82 freshmen say fuego, 10 freshmen say fajita, none said zombie because they're gross. Sophomore, 100 fuego, 35 fajita, and you notice that. I said sophomore. I was actually wrong. The junior class is the largest. I need to go back and edit that. So my bad. Those of you that said junior, I think some of y'all did. Olivia's upset now. She got all the other ones right. She was like, bam, 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 but she missed the largest class. So junior actually was largest by 5. Really hard to tell with this one. But I did want to talk about these two aspects and having them closer together, kind of led into that. So junior 21, 114, and 5, senior 102, 20, and then no zombies. So total of 489. So forget my answer on A because it's wrong. Let's see, I'm going to fix that real quick, actually. Let's see here. Give me just a second. Not immune to the technical difficulties because my computer is not loading very fast. Okay. All right. Let me share my screen back with you guys and then we'll hop back in. Let's see. All right. That looks better. Let me know if y'all have issues reading that. Okay, so the junior class appears to be the largest because its bar is the widest. Same reasoning, and it is. Now that you have a two-way table, it definitely would be the widest. All right, do the events zombie and freshman appear to be disjoint? They do appear to be disjoint because there are no freshmen who prefer the zombie flavor. I believe that's what Kirsten said. There's no overlap between freshman and a zombie. There's a 0 here, okay, in the two-way table. And then the last one, do the events junior and fajita appear to be independent? We said they do not appear to be, and I added the little probability note here. The probability of being a junior, you could do this either way. You could say probability of being fajita does not equal the probability of fajita given junior. You can do it either way. So the probability of being a junior is 140 out of 489. Okay. And that is not going to be equal to the probability of being a junior given that you're fajita. So 114 over 179. Clearly, those two proportions are not going to be equal to each other. 114 over 179, not equal to 140 over 489. Okay. So that means they would not be independent of each other. So with a two-way table, you can actually prove it with the numbers. With a mosaic plot, you kind of just have to, state that it appears that there's not, and that sort of thing. All right. So any questions on mosaic plots before we jump into scatter plots and that sort of thing? Any questions on the mosaic plots with the probability? It is two variables, but this section of two variable data feels different to me than like two-way table and mosaic plots. Any questions in the chat? Sorry for the little pause there with my technical difficulties. Didn't intend for that to happen. All right, let's go ahead and look at scatter plots. So the main thing we're going to review in this little review section to kind of prompt us into what happens when the data is not linear is we have things called influential points. Okay, so here's a sample scatter plot here, and we have influential points. So an influential point is any point that if you remove it, it changes the linear relationship substantially. All right. And there are two types of influential points that we're really going to focus on. You have outliers, and you have what's called a high leverage point. Okay. Both of those points are going to influence the graph in some way, but they're going to influence it in different ways. Okay. An outlier is a point that has an extreme response variable value. So it's going to have an extreme Y value. And an outlier is not going to follow the general trend. So the one all the way in the sky, maybe we'll see. Hang on to that thought for just a minute, Allie. And then high leverage point is going to be a point that has an extreme explanatory variable, which is the X value. Okay. So it's going to have a high X value. Okay. So outliers. The following scatter plot has one very apparent outlier. All right, so I'm going to create a poll. And I want you guys to answer that. Not in the chat. So click over there on polls and vote for which one you think is the outlier. The most apparent outlier. All right. So we have a lot of B's in the poll, and then in the chat we have an A and an E. So we'll look at those, kind of all those different options there. Okay. So the most apparent outlier is going to be B. I can agree with A because that is a pretty large distance from the data from the regression line. Okay, so I can agree that A might be an outlier because that distance does seem pretty large, but comparison to B is definitely the most obvious. So again, remember an outlier is one that is extremely far off. It's extreme in the way that it's far off of the line. It has a large Y value. So B is at 12, where it should be predicted to be at 8.5-ish. Okay, so that's a pretty big jump in the Y direction. So that's going to make it the most apparent outlier. And if you take that point out, it's probably going to change the regression line to go a little bit more steep, because all of these values down here are down. So it's going to tilt the regression line probably a little bit down here. Or maybe the E does something and makes it go the other way. But B is definitely going to be an influential point there because it is affecting the way the line goes through. And we'll look at that more specifically in a second. Okay. So here is the two data sets with and without the outlier. So here is our data set with the outlier. We have a, trying to not move that there. Oh, go back. Okay. So we have our, you can see our slope and our y-intercept for our regression line. On the left-hand side is what happens when there is an outlier. Okay, which is the regression line 4.73 plus 0.56x. And that is with point B being left in the data set. And then you have the one where we took the outlier out. The picture doesn't look as much different. But if you look at the scale, the scaling is different. Okay, the other one goes from, the one without the outlier goes from 5 to 13.5, where the other one goes from just 5 to 13. So it did kind of skew things a little bit, which the lines don't look much different, and it didn't affect it as much in our regression line. Our y-intercept is 3.38. It went down like 1.5, which is a good bit. So you can see a shift from here down to where it's at down here. So there is a shift. It does play a part in the regression model that we would be using to make predictions. And then our slope actually increased a little bit. So it made our line a tad bit steeper to try to more so correlate with these points as opposed to that one, with this one not affecting it. So it did make it a tad bit steeper, lower y-intercept and steeper to more so match these four. But then that guy over here still kind of pulling things in. Okay, so outliers are extreme, and if you're kind of gathering the big picture here, outliers are extreme in the way that they have a larger than normal y value. Okay, so the other option is the high leverage point. So which one of these 5 points is going to be the high leverage point? So let's do another poll. And you guys can answer that one. I'm going to see, I got a few questions here. Okay. Kirsten, hopefully we're answering your question right now on what's a high leverage point. We'll talk about that more in just a second. And Kate, will the number ever be shown horizontally? Can you retype that question and finish it? I just want to make sure I'm clear on what you're asking. So once you've answered the poll, Kate, if you would go and retype your question. And I'll hop back over there. All right, you have to scroll down. Once you hit polls, you have to scroll down. Okay, so if you see the first one, you scroll down and you get the second one. All right, so we have D, 1 vote for D and 5 votes for E. All right, and the answer is E. Okay, and the reason why is because all of the data is between, I need to see that axis there. See if that helps. Probably not. No. So all of our data is between 4 and 10. And then you have that 1 point at 15. Okay, so 15, 12 over here at E. So there's a pretty big significant jump from D to E. So the high leverage point, and this was one of the questions in the question box down here. is that a high leverage point is going to have an extreme X value. Okay. So B had an extreme Y. It was at 12, where most of its counterparts it was comparable to was at 7 and 8, somewhere in there. Okay. But B was at 12. So it was a big jump up in the Y direction for that one. Oh, I clicked. So it was a big jump up in the Y direction for B, whereas E is a big jump in the X direction. Okay. So it's kind of an, without using the word outlier, it's the one that is not like the rest of the data in the X direction. So if you separate your X and your Y column, like good old fashioned algebra 1, if you have one that has a significantly strange X value, that's going to be a high leverage point because it's going to make the line tilt in one direction or the other. And that's what we're going to see on the next part. Okay. So here's the model before you're removing the high leverage point and then after removing the high leverage point. And I mean, that y-intercept changes quite a bit. It goes from 4.73 to 1.19. And the slope also changes from 0.56 to 1.15. So it makes it have a much larger slope. So when we take this point out, it makes the line steeper. Again, you can see the line kind of looks the same because of the applet that I used, but the x-axis changed significantly. It goes from 4 to 14 on the original model, and now it goes from 4 to 9. So kind of another thing, do you think that the R value is going to be higher with the leverage point or without the leverage point? So the R value, which one do you think would be higher? Okay, I have an answer for without. Without, good. Okay, without. Okay, I was looking at the questions. I'll hop up there in just a second. Yes. So without the leverage point, it is going to be a higher R value. So it's going to be the line is going to match it a little bit better. And the reason why, because if you look at all of your residuals, okay, you have these residuals that all line up pretty closely, with the exception of that one outlier. Okay. Whereas here, I mean, this one is far off. This one's close. This one's close, close, close. But you have kind of two far off points. So the average residual amount, which is kind of goes into how you calculate the R value, is going to be higher here than it is over here. The points line up against the line more so, with the exception of the outlier, but you have an outlier on both of them. On the line without the leverage point. Okay, so it does change the model drastically. So again, just to kind of review, kind of recap, the outlier is going to be the one that's an extreme Y value. The high leverage point is extreme X value. Okay, both are influential points because they affect what the model is going to look like. Okay, so let's look now at what happens when the data does not look linear. What can we do when the data looks maybe quadratic or cubic or even exponential? What can I do to my data to make it so that it does follow a linear regression pattern and we can do our slope and y-intercept? Okay. So we're going to look at two potential nonlinear patterns, the two that I just touched up. Draw a squiggle. Unfortunately, that wouldn't work. It might match up to the points, but how are we going to really use that for much? So if they are related by power, okay, like if they're quadratic or if they're cubic. So if you have an equation like they follow the pattern ax squared, okay, as one we'll look at in a minute, then what you can do is you can take all of your data points and you can take the log or the natural log of x and of y. If you do that to both of them, it's going to make the points fit a more linear pattern. So take all your x values and take the natural log or the log of it. Take all of your y values and take the log or the natural log. It doesn't matter what base you use, okay? You can use log base 10, log base e, which is natural log. It doesn't matter which one you use. I know, Olivia, right? This is one of the few sections in stats where it's like math. So some of you, there's really two types of stats people. There's the ones who like the math and the numbers, and then there's the ones who like the science behind it. So if you're the math stats person, you might actually really like this. If you're not, then hang with me. It's really not that bad. There's a few little review of algebra, and then you'll be okay. So again, if it's related by power, like a quadratic or a cubic equation, you're going to take the log or the natural log of both sides. And if it's related by exponent, like an exponential curve, so like 2 to the x power. Okay, so not x to the second power, but 2 to the x power. So an exponential function, you're only going to take the log of y, which if you think about that, that makes sense because the log or the natural log is the inverse of exponential. That's how we generally solve equations. We take the log of both sides and we solve it out. But if we take the log of just the y side, it's undoing the exponent and making it more just like a regular old linear equation. Okay, so that is what we're going to do there. That's kind of the approach we're going to use. All right. So the first example we're going to look at says the relationship between the amount of water that baby chicks drink every day and their age can be modeled by the following equation. So the natural log of y hat. Somebody in the chat remind me why it is important to put the hat over our y when we're doing regression models. Why do we need the hat? Because he's fancy. It's because it's the predicted y value. Yes, Kirsten, good job. It is. It is very important, especially with the exam only being free response. It is very important that if you're dealing with regression, your y needs to have the hat. Okay, Israel says because we didn't have the actual p-value. That's true when we're talking about inference. So the p hat is like a predicted proportion based off of our sample. And it's the same way with the y hat. We don't really know what the ounces of water that the baby chick's going to drink, but we do have a prediction based off of this model of data points. And the prediction is why the y has a hat. Now the x is the number of days old the baby chick is. That we know how old the baby chick is. Okay, but we don't know how much water they're going to drink for sure. Okay, but we can predict it based off of this model. Okay, so the first question is, were x and y related by power, or are they related by an exponential function? So did we take the natural log or the log of just the y, or did we take it of the y and the x? Take a minute, and if you have to hop back over there, you can on the last one. Okay, yep, we took the log of just the y. So what type of relationship does that give us? Is it a power relationship, like squared or cubed, or is it an exponential function? I can look back. We have a few different options. So let's see. So we took the log of only y, so that's going to be an exponential function. So if we were thinking of a scatter plot here, okay, with x being the number of days old and y being the number of ounces that they would drink, okay, it's going to be curved up. It's going to be a exponential function. But we can undo that by taking the natural log of y, and then it turns it into a linear function that we can use. Okay, so basically our x values were staying untouched. Day 1, day 2, day 3, day 4, x's are staying as is. And then our y, we're taking the natural log of that. Okay, so if we had a baby chick at 1 day old and tracked how much water they drank, we would take the natural log of the number of the water they drank. And then the data set where x is the number of days old and y is the natural log of the number of water they drank, then it would be a linear equation like this. Okay, so basically our x and y column for our scatter plot is x and the natural log of all the y's that we originally had. Okay, it would curve up because the older a baby chick gets, the more water they're going to drink. So we clarified it was exponential, the age of baby chicks, and the amount of food. I'm going to say water. Amount of water appeared to be related by an exponential curve since natural log was only applied to y. Okay, so that is the kind of knowing what kind of function we were dealing with. And so the next part, and this is really common that you might have on the AP stats exam. What is the predicted amount of water that a baby chick will drink at 13 days old? Okay. So how are we going to start this question? What would be the first thing that we would do to find the predicted amount of water that a baby chick would drink? Plug in 13 for X. That is correct. Okay. Plug it in. That's right. Okay. All right. And we get 3.94. Josie carrying us through there. All right. And does anybody know where can we go from here to find y hat? This is just a straight up algebra question. How can I rewrite this? Kirsten, bam, raise e to the 3.94 power. That is correct. And that gives you 51.42 ounces. Okay. So that would be our answer. Pre-cal, Algebra 2, it's in both of them, guys. I'm sure your Algebra 2 and pre-cal teachers hammer this home over and over and over again. So 51.42 ounces is the predicted amount of water that a baby chick would drink at 13 days old. Now, clearly, if you go much past 13 days, this model is not going to be accurate. Okay. What is the word we use in stats when we take a model like this that maybe Kirsten beat me to it. Extrapolation. That's right. So when we take a model where maybe all of the scatter plot, all the points we use for our scatter plot were from days 0 to 13. Okay. And then we tried to figure out how much a chicken would drink at 365 days. Clearly, it's probably not going to follow this exponential pattern. Okay. If you plug that in, you're probably going to drown your chicken, and that's not good. So yeah, it ends up being an extremely high number. So that would be an example for extrapolation there, because we are taking a model meant for baby chicks that are just a few days old, and trying to use that same model for an adult chicken wouldn't work. Okay. So any questions on that? Every question I went back to like AP Classroom and looked at old exam questions were worded this way. They give you the example, but you need the algebra behind it to do this. Okay. So I did want to touch over that. I didn't want us at Fiveable to miss that little detail there on how we can change data when it's exponential to make it more of a linear fit, or change it when it's quadratic or cubic and make it more of an exponential fit. Okay. All right. So let's look at another example. So the height of a ball launched in the air by a really fancy scientific catapult, I mean, I'm talking like top of the line here, is modeled by the least squares regression line below. Natural log of y hat is equal to 4 natural log of x minus 3.1, where x is the number of seconds since the ball was thrown and y is the predicted height of the ball in inches. Were they related by power or an exponential function? Y'all are beating me to it. Y'all are figuring this out. Okay. It is power. And then the other thing we're going to do is what is the predicted height of the ball after 6 seconds. So y'all take a minute and calculate that. Calculate what the height of the ball is going to be after 6 seconds. And, post your answer in the chat below, and then we'll look at that. And then we'll take some questions. I'll go back to and answer people's questions from earlier. If you're still waiting on that answer, I haven't forgotten about you. I will get what you need there. If you don't have a calculator at home, I do want to mention this. The TI-84 emulator software is free for 60 days. They have it for Chromebook, Mac, and Windows. Okay, I will find the link real quick while y'all are finishing that up, and I'm going to post it in the chat if you need a TI-84 to use for your AP Stats exam. Okay, and of course you can do exponents and powers and all that good stuff on there too. So give me just a second to do that while y'all are calculating that. They have made that free during the pandemic, so that's a really nice added touch that you can use. It's a free 6-month subscription. If you're using the TI Inspire, they have that app for the iPad, also free for download in the App Store. Okay, I might download that because I would love to have an Inspire and be more familiar with that. So anyways, here is the link. It looks like you can go to select software for students and download the calculator that you might need. Okay. All right, so let's go back to the question here. So you're right, they were related by power because the natural log was applied to both variables. Again, it doesn't matter what base you use, natural log or log. All right, so we're going to plug in natural log y hat equals 4 natural log of 6 minus 3.1. That gives us 4.06. Going back to the same thing we had before, we need to apply that power to, or e to that power. Now, if we would have had log here, we would have done 10 to the 4.06 power, and that gives us 58.38 inches. So that is a pretty fancy catapult there, I will say. Okay. And then I wrote it out in sentence form. That gets you the context points. If you wrote inches, that might be enough for context, but I think a sentence there explaining exactly what that number means is a great interpretation of that answer that you have. Okay, so I think that is good to add that. Anytime you have a number, it's always a good idea to add some sort of explanation as to what it is. Okay. Any questions on that? Yeah, 58.38. All right, so comments or questions. If you have any questions, ask them ask a question or in the chat. Chat's fine. I'm going to go through the questions that were already asked and answer those. High leverage point we discussed. So AP did release the specific number of questions on the exam. There will be 2 free responses. The first one you will be given 25 minutes to do and 5 minutes to upload. The second one you will be given 15 minutes and 5 minutes to upload. Okay, so 25 and 5, they're weighted 55%, 45% for your exam grade. The 25-minute question is not an investigative task. It's not the number 6. It's going to take in a lot of areas in AP Stats, but it's not going to be that investigative task that requires you to use what you know, but then also use that kind of idea and inference to make new assumptions off stuff you haven't done. So like last year, it was like creating a bootstrap sample. You're not going to have to do anything like that. Everything should be familiar to what you've been preparing for, but it's a longer free response than what we're used to. Probably not like 2 or 3 or 4 parts, maybe 5, 6, 7, 8 parts. Bringing in maybe probability and inference at the same time, or describing a distribution along with some probability or something like that. Okay, so we'll definitely have a lot more on that with the cram pass, and the Q&A sessions are great for that too during the day. There are some streams available on Fiveable that are free, that are Q&As for stats. I think it's at 3 o'clock on Mondays, and that. So Also, on Mosaic plots, will the horizontal values ever be shown numerically, or do you always have to guess with your eyes? The horizontal amounts very well could be shown. Okay, now the horizontal value and the vertical value is going to be from 0 to 100% or 0 to 1.0, something like that, because it is capturing the percentage going of classes in the example we did. And then the vertical axis is capturing the percentage of Taki preference. Okay. How would you type p hat for the real exam? You can, I was able to copy and paste it earlier from Google Docs. If you're typing, you could just probably write p dash hat, so something like this. Okay. Okay, just typed in the chat. That would be good. I think if you did, p dash hat would be good. They also said you could write and send pictures. My personal preference would be to write out your answers and then upload them onto the platform. I think that would be a better way of showing your work. But you could type it up if that's what you preferred to do, and you could write p dash hat. Also, maybe you could create like a Google Doc where you could copy and paste from. I don't know how if they're going to lock down your browser though, so I really don't know about that. Anytime I'm typing up stuff for stats, I'll have like p hat, x bar, things like that already ready for me to copy and paste into my whatever document I'm working on. But that's a good question. I would prefer probably to write things out because that's what you're more so used to, unless if your teacher is using things where you've been typing in answers a lot. Okay. Any other questions before we close out the stream? I appreciate you guys joining. Mosaic plots was a good, fun topic for me to look at. It's the first time I've done that. I had fun building that one on Microsoft Excel, and also looking at the departures from linearity and doing some actual math instead of statistical type math. So I'll give you a few more minutes to ask questions, and then we'll close things down. Make sure if you have your cram pass for AP Stats, I believe the stream tonight is on regression. So some questions that we kind of touched on a little bit. R value, slope, y-intercept, being able know how to interpret those are really important. And you can hop over there at, I believe it's 8 o'clock Central, 9 o'clock Eastern time. So you have a little bit of a break. And then you can hop over there and watch that stream if you have a cram pass purchase. If not, I think there's still some available. I think it's a great way to prepare for the AP Stats exam. You've all worked really hard this year. I hate for the circumstances to discourage you from not finishing strong. And I think the cram pass is a great thing you can take advantage of to make sure you get a full review of the AP Stats content necessary for the exam. Okay. I don't see any more questions, so I'm going to go ahead and end this broadcast. Let me know. Let us know if you have any questions, and we'll see you next week.